In the intricate web of the global technology industry, one company stands out as a silent giant, wielding unparalleled influence over the future of our digital lives. This company operates behind the scenes, yet its impact is felt in every corner of the tech world. This company is ASML, a Dutch multinational corporation that few outside the tech world have heard of, yet one that plays a pivotal role in shaping the landscape of modern technology. Despite its low profile, ASML's contributions are monumental, driving advancements that touch nearly every aspect of our digital existence. ASML's story is not one of flashy product launches or household brand recognition. Rather, it is a testament to the power of deep technological expertise and the crucial role it plays in driving innovation across industries. The company's focus on research and development has positioned it as a cornerstone of the semiconductor industry. From the smartphones in our pockets to the data centers powering the cloud, the intricate chips that power our digital world rely on ASML's technology. These chips are the unsung heroes of modern electronics, enabling the functionality and performance we often take for granted. These chips, also known as integrated circuits or microchips, are the brains of modern electronics, processing and storing information at an astonishing scale. They are the fundamental building blocks of everything from consumer gadgets to industrial machinery, making their production a critical task. The process of manufacturing these chips, however, is incredibly complex and demanding, requiring extreme precision and cutting-edge technology. It involves multiple stages of fabrication, each demanding meticulous attention to detail and advanced engineering. This is where ASML steps in, providing the critical tools that enable chip makers to produce the most advanced semiconductors on the planet. Their equipment is essential for achieving the high levels of precision and efficiency required in modern chip production. At the heart of ASML's dominance lies its mastery of a technology known as extreme ultraviolet (EUV) lithography. This technology represents a significant leap forward in the ability to create smaller, more powerful, and more efficient chips. This groundbreaking technology, which we'll explore in detail later, has become indispensable for producing the most powerful and efficient chips, driving the relentless march of Moore's Law, the observation that the number of transistors on a microchip doubles approximately every 2 years. EUV lithography is a key enabler of this trend, allowing for the continued miniaturization and enhancement of semiconductor devices. As the world demands ever faster, more capable, and energy-efficient devices, ASML's EUV lithography machines have become the gatekeepers of technological progress, their importance only set to grow in the coming years. The future of technology, from artificial intelligence to quantum computing, will be built on the foundation laid by ASML's innovations. Their work ensures that the pace of technological advancement continues unabated, driving forward the digital age. Imagine shrinking a picture of the Mona Lisa onto a grain of rice. This feat of miniaturization is akin to the precision required in modern semiconductor manufacturing. Now, imagine doing it with billions of transistors, each a fraction of the width of a human hair. These transistors are the fundamental building blocks of the digital world, enabling everything from smartphones to supercomputers. That, in essence, is the challenge faced by chip makers, and it's a challenge that ASML's EUV lithography machines are uniquely equipped to handle. These machines are at the forefront of technological innovation, pushing the boundaries of what's possible. Lithography, in the context of semiconductor manufacturing, is the process of using light to etch intricate patterns onto silicon wafers, creating the transistors and circuits that form the building blocks of microchips. This process is akin to an artist etching a masterpiece onto a canvas, but on a scale that is almost unimaginable. EUV lithography takes this process to an entirely new level of precision. It allows for the creation of features that are incredibly small, enabling the production of more powerful and efficient microchips. It utilizes extreme ultraviolet light, which has a much shorter wavelength than the deep ultraviolet light used in previous generations of lithography machines. This shorter wavelength is crucial because it allows for finer details to be etched onto the silicon wafers. This shorter wavelength allows for the creation of much smaller and more densely packed transistors, enabling chip makers to cram more processing power into ever smaller spaces. This is essential for the continued advancement of technology, as it allows for more powerful and efficient devices. The magic of EUV lithography, however, doesn't end there. It's not just about making things smaller, it's about enabling new possibilities in chip design and performance that were previously unimaginable. It's not simply about shrinking transistors, it's about pushing the boundaries of what's possible in chip design and performance. This technology opens up new avenues for innovation, allowing for the creation of chips that are not only smaller but also faster and more efficient. The technology behind ASML's EUV lithography machines is nothing short of extraordinary. These machines represent the pinnacle of engineering, combining cutting-edge science with precision manufacturing. These machines are marvels of engineering, each one a testament to decades of research, development, and innovation. The level of detail and precision required to build and operate these machines is staggering. They are also incredibly complex and expensive, with each machine costing upwards of $150 million and requiring an entire building to house. This investment is necessary to achieve the level of precision and performance required in modern semiconductor manufacturing. The process of generating and manipulating EUV light is incredibly challenging, involving lasers, mirrors, and a vacuum environment more extreme than outer space. This environment is necessary to ensure that the EUV light can be precisely controlled and directed onto the silicon wafers. Despite these challenges, ASML has managed to not only master this technology, but also to continuously refine and improve it, pushing the limits of what's possible in chip manufacturing. This relentless pursuit of innovation ensures that the technology continues to evolve, enabling the creation of ever more powerful and efficient microchips. ASML's technological dominance in EUV lithography has translated into a position of unparalleled financial strength. This strength is not just a result of their cutting-edge technology, but also their strategic foresight and relentless innovation. The company has consistently outperformed market expectations, riding the wave of surging demand for semiconductors driven by the relentless growth of data centers, artificial intelligence, and the ever-expanding Internet of Things, IoT. These technologies are becoming increasingly integral to our daily lives, creating a robust and sustained demand for advanced semiconductor solutions and other data-hungry technologies. The proliferation of smart devices, autonomous vehicles, and high-speed 5G networks further fuels this demand, positioning ASML at the heart of a technological revolution. As the sole provider of EUV lithography machines, ASML enjoys a virtual monopoly in this critical segment of the semiconductor market, giving it significant pricing power and a commanding market share. This unique position allows ASML to set industry standards and drive innovation at a pace unmatched by its competitors, giving it significant pricing power and a commanding market share. This dominance not only secures ASML's financial future, but also ensures that the company remains a pivotal player in the global tech ecosystem. Investors have taken note of ASML's remarkable performance, rewarding the company with a soaring stock price that reflects its strategic importance and future growth potential. The confidence of the investment community underscores the market's belief in ASML's continued success and its ability to navigate the complexities of the semiconductor industry. The company's market capitalization has skyrocketed in recent years, propelling it into the ranks of the world's most valuable tech companies. This meteoric rise is a testament to ASML's strategic vision and its ability to execute on that vision with precision and agility, propelling it into the ranks of the world's most valuable tech companies. ASML's ascent is not just a story of financial success, but also one of technological leadership and innovation. ASML's strong financial position has also enabled it to invest heavily in research and development, further cementing its technological lead and ensuring its continued dominance in the years to come. These investments are critical as the company seeks to push the boundaries of what is possible in semiconductor manufacturing, further cementing its technological lead and ensuring its continued dominance in the years to come. By continually advancing its technology, ASML not only meets current market demands, but also anticipates future needs, positioning itself as an indispensable partner to the world's leading tech companies. However, ASML's financial success has also attracted scrutiny, particularly as governments and regulators around the world grapple with the implications of such a strategically important company, wielding so much influence over a critical industry. This scrutiny highlights the delicate balance between technological advancement and regulatory oversight, particularly as governments and regulators around the world grapple with the implications of such a strategically important company, wielding so much influence over a critical industry. The global semiconductor supply chain stability and security have become national priorities for many countries, adding another layer of complexity to ASML's operations. The company's dominance in EUV lithography has raised concerns about potential bottlenecks in the semiconductor supply chain, prompting calls for greater competition and diversification in the market. These concerns underscore the need for a more resilient and diversified supply chain to mitigate risks and ensure the continuous flow of critical components, prompting calls for greater competition and diversification in the market. Despite these concerns, ASML's financial performance remains strong, a testament to the company's technological prowess and the insatiable global demand for its cutting-edge lithography machines. The company's ability to maintain its leadership position while navigating these challenges speaks volumes about its strategic acumen and operational excellence. Despite these concerns, ASML's financial performance remains strong, a testament to the company's technological prowess and the insatiable global demand for its cutting-edge lithography machines. As the world continues to embrace digital transformation, ASML's role in shaping the future of technology becomes ever more critical, ensuring its place at the forefront of the semiconductor industry for years to come.